Okay, take your calculators out. Find the probability that z is less than 1.2, given the mean is 0 and standard deviation is 1.
Less than 2.
1.2. Number 2. If the probability that z is less than a is 0.3875, with a mean of 0 and standard deviation, normal distribution, find a. Probability that z is less than a is 0.3875. Remember, we're going 3 significant digits. What's the symbol used for the mean? One of 2 symbols used for the mean. And number 4, the symbol used for the standard deviation. And number 5, what the formula is to convert a raw score to a z-score. All right, how's it? Oh my God.
Who?
I went to Chicago last weekend. We did the Inspire, TI Inspire.
Oh, yeah.
We're going with those calculators
One
next
more.
year.
Cool.
It's
One more.
like, they are cool
Great.
as can be.
Are you allowed to use those in AP though?
Yeah, as long as you don't have the CAS. CAS is computer algebra system,
Oh, that
which
counts.
does like derivatives and integrals. Is yours CAS? Okay, so if it does it symbolically, they're not allowed. Well, actually, all of them are allowed on the SAT, but IB and AP doesn't allow the CAS. No, AP allows everything. IB and ACT doesn't allow the CAS. So we're going to go with the ones that don't allow the CAS. But I mean, you could do a whole portfolio. You could write a whole portfolio assignment on there as a file and save it and send it to your computer. It's amazing. It's really cool. All right, I have 0.977. No? 0.885? Really? Okay. What did you go from?
-5 to 1.2.
Oh, what did I just typed it in wrong? Okay, number 2 was, really? 0.366? No, negative 0.286. Okay. Number 3 is mu or x bar. Number 4 is sigma, lowercase sigma. And number 5 is x minus mu over sigma. X minus the standard deviation, the mean over the standard deviation. Yeah?
Did you put 5?
All right.
Did you put 5?
For which
Take
one?
your homework out.
The symbol for standard deviation.
I put, rolling whatever. The practice stuff, right? Alright, the practice stuff?
Yeah. No, not the practice
No.
test, the normal distribution assignment.
Oh, I did that yesterday.
All right, so number 1, you should have gotten. Oh, let's go over cumulative frequency first. Right? All right, so for number 1, the median, I got 135 or 137. And for the interquartile range, 12. Okay. Number 2, A was 152 and B was 44 minutes. Yes.
If it says estimate, how do they like grade it?
They usually give you a range that's between like, and usually the grading rubrics are wrong, but like for the median for number 1, they'll probably give you like, what is that, 1, 2, 3, 4, 5. Like you could say 135, like 133 to 137 or something like that. They'll give you a pretty generous range.
Okay. And so for 2A, I got 147.
147.
Yeah, so like 140.
Number of students who spend between 20 and 40 minutes eating lunch. So you're going to draw a line at 20, and when you go down, it's 20. Or no, it's not. Is it?
It's like
19 or 18?
32.
Okay. Yeah, I must have been doing this in the dark. My line's completely off.
Okay.
2, 4, 6, 8. So each line is 2, right? So it should have been 18. No. Oh, I know
You
what I did.
started, yeah.
Yeah, I started at 20. That's what I did.
So each little line is 4.
Okay. So on the y-axis, what is each line? 2, 4, 6, 8. Still 2? So 22, 24, 26.
I like them.
Actually,
Yeah, it's 4.
Here's
You go 5 lines between 20 and 40.
Oh, each line is 4?
Yeah.
Okay. All right, so you could go between, they would probably give you between 24, 28 and 32. Right?
Mm-hmm.
For the bottom one?
wait, but why? It's saying between 20 and 40 minutes.
When you go to 20 on the minutes, on the x-axis up to the curve, on the y-axis you're going to be going between 28 and 32. So your lower guy is 28, let's say, and then you go up from 40 up to the curve and it's going to be around 184 or 180, right? Okay, so around 152. Let's see what they did on the grading rubric here.
Minus 30.
Well, they didn't actually, the grading rubric was wrong. So I have 180 and 152. So the interquartile range is, 152. No. The number of students would be 180 minus 28, around there, so 152. Give or take a few.
Yeah.
All right, B, 20% of the students spend more than X minutes eating lunch. So you're talking about the top 20%, right? So you're going to go really 80% times 250. Because I need to get the top 20%. Because it's spending more than X minutes.
Well,
So you go from 200 on the y-axis over to the curve and you get about 44. Yes or no?
Yes.
If 20% of the students spend more than X minutes, then I've got to look at the top 20%, which is 80% of 250. Do we all understand that?
Yeah, the bottom.
Okay, and when I see your graphs, if I'm the grader and I'm looking at your paper, I should see lines going on your graph. If you don't have lines, generally you don't get credit for showing work, because that's your work. Do you understand? And that's also what allows you to get partial credit. All right, and then number 3. The median height is 11.5-ish. And you complete the following frequency table. The frequency for between 10 and 15 is 8. Between 15 and 20 is 5. And between 20 and 25 is 4. And I'm subtracting the frequencies, correct? Okay. And then to estimate the mean height, now I just use that frequency table. So I multiply the mid-interval values times the frequency. The mid-interval values are 2.5, 7.5, 12.5, 17.5, and 22.5, and you get 30.
30?
No?
We just divided by 30?
Oh, 11.8. Okay. 11.8, 11.8. Any questions there? No questions. All right, normal distribution. I'm going to sort of graph these. Remember I said I suggest that you graph them. So the probability that the absolute value of z is less than or equal to a. Absolute value of z is less than or equal to a means that z lies between a and negative a. And so we want the probability, if I draw this, let's say here's negative a and here's a, and so I'm looking for the value of a for which the probability of that area is equal to 0.75. So, anyone want to give me a suggestion as to how I do this? John Boone?
Inverse normal.
And what are you going to do with that?
Plug in 0.75, then comma 0, comma 1 to find a, and then that.
Well, if you plug in inverse normal and you go 0.75, then you're going to get that, this is A, you're going to get that this whole area from negative infinity to A is 0.75. And that's not what you're looking for. Yes?
If you do 1 minus the probability that they give you, and then figure out the a value for that, then it will just be the same.
Okay, so 1 minus that, 1 minus 0.75 is 0.25.
Yeah.
That would mean that this area is 0.25, right? And so I could go inverse normal of 0.25 and I would get negative a, right? where I would get a negative value which represents A. And so you could go from there. So is that the way you did it?
Well, I just figured that out. I did it wrong.
Okay. So let's do that on our calculator. Go inverse normal 0.25. And what do you get?
Negative 0.674.
Really?
Yeah. That's what I put.
Oh, wait a second. No, that's not going to work.
Wait,
Could you use my answer?
Because this is wrong. This graph that I drew was wrong when I was explaining to Jonathan. Right? If you do that, this is what I want. You understand?
Yeah.
This is the importance of writing that, graphing that. If you would have done what we suggested, you're going to get this value where this is 0.25. I don't want that value. I want the area between the two to be 0.75. Yeah.
Oh, wait, so could you have used my answer, like 1 minus 0.674, and then 1 minus 2 times whatever that value is? So you kind of eliminate the sides and just get the middle.
Eliminate the sides.
So if you do 1 minus 0.674, which is,
Okay, our answer is 1.15.
Oh, I got that.
Okay, so how did you do it?
I just divided the 0.25 in half. So that way, on each side of the A value, it'll be 0.125, which adds up to 25, or 0.25.
Well, I'm not following you.
Like,
Okay, you found that value. What did you get here when you did inverse normal 0.25?
I got
did it.
like
He did it.
0.674.
He did 1 minus 0.75, which is 0.25, and he divided it by 2, so that each side would get, if you add them together, would be 0.25.
So the middle part.
So the middle is.
So the middle part is 0.75.
Okay, all right, so what did you get when you did inverse normal of 0.25? Isn't that what you did?
No, he divided
No,
by
I did
2.
0.125.
0.125. Oh, okay.
Half.
All right, okay. And then what'd you get?
1.15.
Negative 1.15?
Yeah.
Okay. All right, that makes sense. Something else here's what I did. I said that if this whole thing is 0.75, I'm going to divide it by 2 and I'll get that. Right? So that's 0.375. So this is 0.375. Are you with me? And so I just took 0.5 minus 0.375, which is 0.125. Yeah, so I did it kind of indirectly the same way that you did it. And then I found A that way. Okay. Number 2, on your calculator, you get 0.910. Now I want to go over some notation that you should probably write down. In statistics, when you have a distribution, they write the notation like this. They say X is normally distributed. It's a normal distribution. The variable X is a normal distribution, and they give the mean and the standard deviation. Okay?